technology.
What on earth is a quantum computer?
Bits, qubits, try all the codes at once.
Whichever nation first develops a practical quantum computer will have a tremendous advantage.
Quantum supremacy.
This is a quantum computer.
I see a lot of news about quantum computers and they are extremely confusing.
It was really well done, and I still need to rehear it.
But also, it's often wrong. Quantum computers aren't supercomputers. They aren't the bigger and better version of what we are using right now. They are something totally different. And that difference is actually the key to understand why there is such a big deal and why governments across the globe battling together in order to make these quantum computer first. Quantum computers are wild. They are on track to change what we can build and how we understand this entire world. They are kept at temperature which is cooler than space. But if you think you really understand what they are and how they work, you probably are wrong. At least I am. And that's where this video will start. Hi everyone, my name is Satyam Srivastava. I'm a management consultant by profession. And on this channel, we try to decipher complex technologies and issues into simpler bits. So let's start. So in this video, I decided to go on a virtual tour to IBM's facility where they have kept their quantum computers along with my fellow YouTuber. And on this tour, we'll try to understand what are quantum computers, how they work, what they can really do, and why should we care about it. And more importantly, to show how these crazy computers might actually impact your life sooner than you think. Let's dig in.
IBM recently unveiled a groundbreaking machine, the IBM Quantum One, the very first integrated quantum computing system available for commercial use. It's unlike any other supercomputer in the world.
Okay, so I'll try to explain quantum computers with an analogy. And this analogy is known as quantum video game analogy. Imagine that you are on a video game map and how you get around depends on how good you are at doing math. You may not want to play this game, but bear with me please. So first, there were no computers. Things like geometry and astronomy took forever. So you have your little pencil and paper and you're traveling across the mathematical map by walk. So it was slow and there were lots of areas that we just couldn't explore because it was beyond our computational ability. But then we developed early computers that allowed us to put in larger data sets and answer problems that had previously been out of reach. These new computers unlocked new areas on our mathematical map. Instead of walking everywhere, we can now ride horses, we can get farther, faster, and we can access areas that were previously inaccessible. But there were still parts of the map that our computer couldn't access. Luckily, computers just kept getting better and they allowed us to solve more and more complex math problems. As a result, our virtual map has transformed. We have roads and cars and we are just reaching areas that were previously unreachable. Better computer means traveling across the map faster and more easily than ever. The thing which one of the physicists said was really important to understand is that quantum computers are not faster cars. Instead, he considered it to be boats because these are developed for an entirely different terrain. A boat may not be necessarily better than a car because they are just built. So with our new quantum computers, we are beginning to navigate these new mathematical waters, solving problems and discovering areas that traditional computers just can't do it.
Hi, I'm Olivia Lanes. I'm a researcher at IBM and I also work on the education and the community team.
That's a quantum computer?
Yeah, but actually this is a dilution refrigerator. This whole thing is basically constructed to keep the quantum computer very, very cold. 15 millikelvin. It's the coldest thing basically in the universe. It's colder than outer space. So here, let me show you the one that we can play with. This is a quantum computer. The quantum computer is a chip in this one here, but this whole thing keeps the quantum computer working at insanely cold temperatures like we talked about. So all of these cables that you see here on the side carry signals down through the fridge into the processor and then they do their quantum stuff and it comes up and it goes to these room temperature control electronics and they turn it into things that humans can understand. So I think it's really funny that when people generally talk about the difference between classical and quantum computers, people are like, okay, well, you know how a classical computer works, right? But the truth is that Nobody knows that. A simplification of it is it comes down to bits. And bits are made out of pieces of silicon, and you have, tens of thousands to millions of them in your computer. And they can either be in the state 0 or 1. We call it the ground state or the excited state. And everything that you type into your computer, like all words, all numbers, all colors, get translated into computer speech. But it's very binary, right? A quantum computer is run on qubits, and they add constructively or destructively, just like waves would. If you were to tap 2 places in a pond, basically you are altering the probabilities while you're running an algorithm.
And it's a common misconception that quantum computers try all the options. That's not right. This is simplified because it's more like a quantum computer kind of watches the entire pond. It watches how all those waves interact and then finds the most likely answer to the question. If this is all confusing, don't worry. All you really need to know is that quantum computers calculate things very differently than a classical computer do. And that makes them good at different things. Quantum computers are not going to be faster at everything when we compare it with the classic computer. It's not good in additions because your calculator and your phone is perfectly good at that. But the things that quantum computers are good at is finding structure in tons of data.
Quantum computers are not going to be faster at everything than a classical computer. It's not good for addition, right? Because your calculator and your phone is perfectly good at that. But the things that quantum computers are good at is finding structure in tons of data. And if you're interested, we can close it back up.
Let's go back to our virtual map and try and understand again. So we have our boats and we are floating around discovering new parts of this map. One of the first new areas of interest is simulating nature. Simulation of nature seems really interesting. Why is nature one of the things? So nature fundamentally is quantum and it obeys quantum physics. We just don't normally see it, but if you look at a molecular level and the atomic structure of molecule, everything has to follow the law of quantum physics. It's really hard to calculate what material or what an atom is going to do past a certain size. So at a certain point, it just can't do it. But if you're interested in developing battery technology or creating new materials that have long chains of molecules, you're going to need a quantum computer. And this is why people are so excited about it. Think of new materials or medicines or molecules that we could make if you could better predict the way that nature behaves at a molecular scale. Okay, so simulating nature is something what quantum computers could be amazing at. But we are also getting closer to another use of quantum computing, of which the people and the government are more concerned about.
Completely new encryption algorithms.
Break encryption.
Quantum-resistant encryption.
A fully functional quantum computer could be built with code-breaking capabilities that could render all forms of online encryption unreliable.
Okay, now the big question is why everybody is so obsessed with talking about quantum computers and encryption. Let's hear an answer from IBM researcher.
So the first major algorithm that was developed for quantum computers is Shor's algorithm, named after Peter Shor. Super nice guy. He invented an algorithm which basically can find factors, prime factors for really large numbers. Why does anyone care about this? Because that's the basis for RSA encryption, which is basically how all transactions on the internet are conducted. And the entire reason that all of our encryption schemes today work that way is because it's basically impossible to crack that with a brute force classical algorithm. It would take, I think it's billions of years. But a quantum computer could do that way more efficiently. We're talking hours to days.
So this global race now makes a ton of sense. Whoever gets a quantum computer to actually do this has a big and obvious advantage over others.
We haven't done that yet. That's one of the ones that requires probably 1 million qubits or more to do, but we're working up to.
So we are not going to be using quantum computers to break all the internet security right now. Today, we are at 433 qubits, the record set by IBM. 400 to 1 million qubits is a big difference. But Olivia is confident that we will get there sooner than you think.
In the next 5 or even less years, we're going to see people switching over to quantum safe algorithms because of this reason.
So RSA goes away and we have quantum safe encryption instead?
Probably. Not all at once,
Yeah.
but gradually you're going to see people do it. We're progressing at an incredibly fast rate. We're solving problems that people didn't even begin to know how to crack 2 years ago. But we've done it. Like every single year, everything that we say we do, we do. Nothing mathematically or physically prevents it. And so if the physics says it's allowed, the engineers will find a way.
That's sick.
So with all these information, what I can picture will adjust this quantum video game analogy a bit. Because as per my understanding, quantum computer is more like a submarine. Because there are different sorts of levels where quantum computers will play a role.
We are just skimming the surface. We're going to keep iterating and improving upon this technology every single year. And we're probably going to discover like new applications that we haven't even considered. It's a bottomless ocean.
I think we can keep almost all of it, which is that our exploration of the other field of mathematics and physics and science was equivalent to other steadily advancing form of transportation around our imaginary video game island. But as I said, I would like to tweak and adjust this analogy to submarine because there are levels to it. It's more like a bottomless ocean where we'll have to go on in order to search for the next bottom. The tech gets better, there's no physical limit. It just continues to improve itself. Here's how Olivia put the dream of how we would actually see quantum computers.
It's beautiful because, like, of course, we all want to make the world a better place. We want to develop technology that's going to enable us to do fundamentally different and better things. But it's also beautiful because, like, part of the human experience is you just want to, like, learn what we are and, like, learn more about the world we live in. And the fact is, the world is quantum mechanical.
And the fact is, the world is quantum mechanical. So there you go. I hope from all of this that you have learned something new and found this video a bit interesting. If you really did, I would really appreciate you subscribing my channel. Keep liking, keep subscribing. So signing off from here, thank you so very much.